Time for fun with math. Here's our ACME thread. We know that we're 10 threads per inch, and we need to know this depth, especially since we're not going to have any way of checking this thread really, except with the brass nut on the compound, which you actually obviously need to use to cut these threads. So there's a simple formula to find this depth of cut. The depth equals half the pitch plus 10 thousandths. So our pitch is 10 threads per inch. Now we have to get that into a decimal, so we'll have to divide that by 1 because it's 1 inch, which is going to equal 0.1. Half of that, 0.050 plus 0.010 equals 0.0. Can make a circle for the life of me. 60. So we're going to have to feed in, or this depth here is going to have to be 60 thousandths. Now, time for curveball. Like all threading operations, including irregular 60-degree threading, we're going to have our compound set at half of the threading angle, the actual thread angle. So this is 29 degrees. We're going to have our compound set at 14.5 degrees. And what that's going to do is when we feed in, we're not actually, our dial isn't actually reading the correct amount as we feed in. We're going to have to feed further to equal that 60 thousandths of an inch. Now we have to figure out how much farther. To do that, I'm going to have to go back to math class and remember all that trigonometry stuff that you went through. Neither do I, because the only thing I remember is saying, when the hell am I going to use this? When can I get out of this class? And that's it. Oh, and I remember what pi equals, which is 3.14, I'm pretty sure. So I had to look all this up on the internet, and I'm going to simplify it a little bit for you. So what we're going to have is our compound is going to make a right triangle. We have to figure out what the hypotenuse is, which is our travel in. So to figure out that, it's to simplify it as easy as I can, we're going to need to know the secant of our 14.5 degrees, which by looking it up ends up being 1.032. Now we're going to have to multiply that by our feed depth, is 0.060. That ends up equaling 0.06192, so we can just call that 0.062. So I'm going to have to feed in with my compound 62 thousandths to equal the 60 thousandths thread depth that I need. Now I have the regular original 100 graduation collar on there, which reads my radius cut. So I can take that full 62 thousandths and end up with 60 thousandths on each end. If I had a 200 graduation dial, I would only be reading the actual diameter. So I would only be taking 31 thousandths here and 30 thousandths here and 30 thousandths here. So I would actually have to feed in to 120 thousandths to equal the diameter of the radius of what we need. Now that I've confused the living crap out of you, and even myself a little bit, let's get to cutting this. I figured might as well show you, how to change the gears a little bit on the Model B that I have for the threading. We're cutting 10 TPI, so the way we're going to do, you can see in these columns here, you got threads per inch, stud gear, idler gear, screw gear, cross feeds, and long feeds. Now cross feeds are if you were to have your star wheel engaged, that is your carriage advancement per revolution, and depending on your gearing you can get all these different combinations. Now your longitudinal feed is just that, your longitudinal feed, which would be your cross slide back and forth for facing, power facing and stuff like that, and that's what this column is here. So we need 10 threads per inch, which is up here. So our stud gear needs to be a 32 tooth. We're using figure number 2 as a diagram, which is our gears are going to look like this configuration here. And Our screw gear, which is going to be this one on the end of our lead screw, is going to be a 40 tooth. So let me set up and see if we can get this going. This gearing right now is set up for the lowest cross feed that I can get off of this, which is about 1,000 inch of carriage travel per revolution of the spindle. So most of these gears are coming out because we're having such a high gear. This is your stud gear right here, which is on the bottom of your reversing bracket. And then according to the picture, we're going to need an 80 tooth gear right here. And then that's going to be directly driving our screw gear, which is going to be a 40 tooth. So this gear's coming out, this gear's coming out. This is getting changed, and everything's getting changed around. Now, depending on what that picture looks like, there are also spacers in here. There's one here to be able to bump the gears out a little bit further to be able to grab this. I'm not going to need that, so you just take it out and put it on the outside to push this gear in further. So let me get all these off and we'll start from scratch. Alright, we have everything off. According to the diagram, we're going to be putting our 80 tooth gear on the top of this bracket here, which is going to engage our, I believe it was 40, our 40 tooth gear, screw gear. Behind this stud gear, there's a spacer, a little washer. You want to make sure that stays in place. Also, all the gears that go on this are keyed. We're going to be putting the 32 gear on there. You can see the key slot in that. You want to make sure that those are the ones that go on there, because this one here, you have two 80 tooth gears in your set. You have one with a key that's thin and one without a key that has this boss on it. You want to use this one here because that boss is going to take up this stud. You can't use this one on there, otherwise it's going to be floating around all over the place. So let's put this on here. This is the nut that goes with this. I have my back gears locked to stop this from spinning. As long as you're gentle with these, you're not going to break anything. You don't want to go Hercules tight. You just want everything nice and snug. Put our 80 tooth gear on there. Now we don't want to tighten this down because we don't know how far it's going to need to slide to make room for this other gear. And there's also washers that go on the outside of these. Make sure you put those on. Washer and nut. You can see where a quick change gearbox comes in handy. Now that's going to mesh with that gear. Then our 40 tooth screw gear. This is also a keyed slot. It's going to slide into there, and we're going to get our spacer, which I put down right here. This will allow that screw gear to either be in close to the shaft or out further when you have the staggered gears, and it's also keyed. That does not need a washer on the end of it. That one we can tighten down. We're not going to be able to get much because we're going to be turning the lead screw when we turn that screw. Alright, now we want to mesh all our gears together. Move that bracket up and down and get it all nice. I'm just going to snug this up. I'm not going to tighten anything because I'll show you what happens. Actually, let me tighten it down and show you what happens when you have these gears meshed too tight. Pull them in so there's no clearance between those gears, and you'll see why you don't want to do that. Hear how loud that is? That's because there's no wiggle room between these gears. So, loosen them up again. Now when I can tighten down, move this banjo around. What you want is a paper's clearance. But to get the hang of this, what you can do, or what I did at first, take a sheet of computer paper, shove it in between the gears. Now it's not going to cut that paper. You want it about that close, tighten it down. Now you'll be able to feed this out and it won't cut the paper, it'll only crimp it. That's about where you want it. And after a while doing it, you can do it just by eye. Now I'll show you the sound difference that makes. How quieter that is. Now I also, on my gears, use, if I can find it, where I put it, there you go. Open gear and wire rope oil. This stuff is, it smells, it's black, and it's very, very sticky. Just give it a little squirt. And you're all lubed up to go. And that's how to change the drivetrain on a Model B. A little pain in the ass at first. After you get used to it going in and out, you can do it pretty quick. Would a quick change gearbox be a little bit easier? Yeah, but I got what I got. Alright, before we get that set up the thread, we want to, or I had to measure 2.9 inches away, and I'm gonna cut the relief. I'm gonna go slightly below the minor diameter of that ACME thread, which we said was 60,000, so I'll go down to 70,000, so that way there I have a 10 thousandths gap to skim over the top of that with my threading tool, so I'm not digging into the other side. Well, there's 0. Should be using oil with this, but obviously I have the camera in my hand, so should be good as long as I go slow. There's 70 thousandths. So let's set it up to thread real quick. Okay, I got my actually, this is one of my pet peeves with these Southbends. Whoever the hell decided to put their protractor on the opposite side of the operator where all the swore falls, it should be killed, honestly. It's the most retarded spot to put it. Anyway, there's my 0 mark. Here's my protractor. Let me walk around the other side and show you, because I can't lean myself over. Right there, we're at 14.5 eyeball style. Obviously I don't have half marks, close enough for government work. And just like if you were threading regular 60-degree threads, your threading gauge comes with a centering tool. Oh. And use it just like your, I'm blocking the light with my arm. Let me switch my camera. Use it just like your fish up against your work, and make sure your bit is perpendicular to where you want it to be, which we are. So let me set it up an overhead view. We'll finally get to cutting this thing. Alright, we're ready to cut. Now we got to set our dials to where we want them. So basically I'm going to pick a spot here with my compound. what I like to do is have my, if possible here, have my compound handle as horizontal as possible. So that way there, all I have to do is grab it and turn it and disengage at the same time. So we're not touching there, so I'm going to set my 0 on my compound right there. We're going to come back to that number every time. That's going to be our reference. All of our feeding is going to be done with our compound. Ready? I'm setting back here. We're going to feed in with our compound just until we raise a chip. Right there. Now I'm going to set my 0. There's my 0. There we go. There's our scratch cut. We're just making sure that we're going to end up with our 10 TPI. We're coming to the end. Now I'm just going to verify visually with a ruler real quick, or a pair of calipers. 1 inch. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, 10 TPI. Now we can keep going until we get to that 62 thousandths depth that we want. Come back to our 0 on our compound. Feed myself in another 10 thousandths. Some oil. And here comes the 2. We're coming to the end of our cut. Disengage and move. Back to the start. In 0. In another 10. Wait for the line. Catch the line. Nothing special about an ACME thread. The only issue is grinding the tool bit. That's the hardest part. And there's no, as far as I know, no preformed ACME threading tools because of the fact that you saw all the different notches on that gauge. So to make a tool for every ACME thread is just, it's not cost effective. It's just not going to happen. So, 0. $35 thousandths. Wait for a line or a number. Now I know I'm digging in a little bit over here. I could have angled this a little bit better. It's not a huge deal because we're going to chamfer the end anyway. Now I'm going to take a spring cut, which I'm not going to move my settings. All I'm going to do is take the same cut we just took. And that's how much our part flexed. I usually like to do it every 2 or 3 times. That'll give you a nice even cut. Catching a line now instead of a number, but you can see our cut falls back into the same space. This is just another spring cut. You can see how much it didn't take off on the first spring cut. The only reason why I'm going very slow with this is because it's my feed screw, so I want it to be as accurate as possible. If this was just a nut or a bolt that's going on a vise or something I'm not really concerned about accuracy with, I can go a lot faster, but just take your time and go at it little by little. I mean, there's no rush. You can see our ridges here starting to tighten up. You zoom in here a little bit. Kind of hard to zoom in and pay attention at it at the same time. I'm just and engage. Trying to give you a good shot of what the hands do. So we're going to feed into our 0 point on our compound, which is right there. This is a spring cut, and wait for a number or line to come around. Caught it there, and we're coming to our end of our cut right there. Feed out, shut off at the same time. One full revolution. Back to your end. One full revolution in, and I'm gonna take that last 2/1000s, and then I'm gonna do another spring cut. And we're out. One full turn. Over. Into our 0 mark. And line, spring cut. That's all there is to any kind of threading. Like I said, most people are scared of ACME threads, but the only scary part is the grinding. As long as you can get through that, just like everything else. Alright, I just finished up. I ran a file over the top real quick just to break the burrs off that raise when you're threading. I also chamfered the end just with the file. You don't want to use a tool bit to do that because you have it sticking out so far from the chuck. If you have to take out the center to do that, your tool bit's gonna ride. This is gonna ride up over your tool bit. You're gonna bend it, and you have to make a new one. So, but here's the original screw, and here is our replacement. You can see the threads are longer, but that's okay because the whole shaft is going to be longer because of the bushing that we're going to be putting on here. But you can see our threads here, they match up pretty damn good. There's the one we cut. There's the original. And if we go over to my machine here, oh yeah, thread's in there nice, smooth as silk. Now let's see if I'm just using this as something to be able to force up against that. There it is. Moves nice. I'm happy with that. Now we just gotta flip it around in our chuck, machine the other end of this, and we'll be done with this section. Then we'll have to move on to the bushing.